In the grand tapestry of the universe, stars are the luminous beacons that light up the cosmos, each with its own life cycle from birth to death. Among these celestial bodies, white dwarfs represent the final stages of evolution for many stars, a serene ending before the ultimate fade into darkness. This video delves into the fascinating journey of white dwarfs, their transformation into black dwarfs, and what this means for the future of the universe. Stars are born from vast clouds of gas and dust, known as nebulas. Under the influence of gravity, these clouds collapse and form protostars, which eventually ignite nuclear fusion in their cores, becoming main-sequence stars. The life cycle of a star is largely determined by its mass. Stars like our Sun spend the majority of their lives in the main sequence, fusing hydrogen into helium in their cores. However, as they exhaust their hydrogen fuel, they enter the next stages of their evolution, expanding into red giants. For stars with masses up to around 8 times that of the Sun, this journey ultimately leads to the formation of white dwarfs. As a red giant, a star expels its outer layers into space, creating a beautiful planetary nebula. What remains is the core, which contracts under gravity and becomes a white dwarf. This stellar remnant is incredibly dense, packing mass comparable to that of the Sun into a volume similar to Earth. White dwarfs are fascinating objects with unique properties. They are composed mainly of electron-degenerate matter, where the electrons are packed so closely that quantum mechanical effects prevent further compression. This state of matter gives white dwarfs their remarkable density. Without nuclear fusion to generate heat, white dwarfs gradually cool and fade over billions of years. They emit residual thermal energy as they cool, shining faintly with a white light. Over time, their luminosity decreases, and they become cooler and dimmer, transitioning through various stages. As a white dwarf cools, it will eventually reach a point where it no longer emits significant heat or light. This theoretical end state is known as a black dwarf, a stellar remnant that has cooled sufficiently to no longer be visible. The cooling process of white dwarfs is incredibly slow, taking longer than the current age of the universe. It is estimated that it would take hundreds of billions to trillions of years for a white dwarf to cool to the point where it becomes a black dwarf. Since the universe is only about 13.8 billion years old, no black dwarfs are expected to exist yet. Black dwarfs, once formed, would be incredibly difficult to detect. They would be cold, dark remnants, composed of carbon and oxygen crystals, and would no longer emit light. These stellar remnants represent the final, eternal darkness that awaits the universe as it continues to age. White dwarfs and their eventual transformation into black dwarfs hold significant implications for our understanding of the universe's future. They are a key component in the life cycle of stars and provide insights into the long-term evolution of galaxies. Studying white dwarfs allows astronomers to perform galactic archaeology, uncovering the history of star formation and evolution within our galaxy. By analyzing the distribution and composition of white dwarfs, scientists can infer the ages and evolutionary paths of different stellar populations. The eventual fate of white dwarfs ties into the broader question of the universe's ultimate fate. As the universe continues to expand and cool, stars will cease to form, and existing stars will exhaust their fuel. White dwarfs, along with other stellar remnants like neutron stars and black holes, will dominate the universe in its later stages. In the far future, after many trillions of years, stellar activity will decline, and the universe will be populated primarily by these cold, dark remnants. Black dwarfs will represent the final stage of this process, marking the end of visible light in the cosmos. The concept of white dwarfs cooling into black dwarfs evokes deep philosophical and emotional reflections on the nature of existence and the passage of time. It challenges us to consider our place in the universe and the fleeting nature of our era.